Okay, now I actually ended that last lecture a bit prematurely because there was one other thing I was supposed to do that I forgot. Okay, the instructions say that if there is an included side or included angle, I have to label it. Okay, so let me take a last look at 8. Is there an included side or angle here? Well, is there an included angle? Do we have an angle that is between two sides that we are marking? No, right? The only side we're marking in this triangle is EG, and the only side we're marking in this triangle is MO. So we can't have an angle between two marked sides. But do we have a side that lies between two marked angles? And I think you can see, yes, EG is a side lying between these two angles, which are both, we both put marks on them. Okay, so EG is an included side. So we're going to say that I'm just going to put a bracket to say this is an included side. And over here, the corresponding included side is MO. This is also an included side. Okay, and there are no included angles here. Let's go on to number 9. Okay. We have two triangles, ABC and EFD, and we're told that side AB is congruent to side EF. So let's make our markings. AB and EF. I'll put a single line through each of those. Side BC is congruent to side FD. Let me put a double marking through those, showing that those two sides are corresponding and equal. And finally, side AC is congruent to side ED, which would be over here. Okay, so those are our markings on this triangle. Can we conclude that these two triangles are congruent? Yes. Yes, absolutely we can. So we can conclude that because of side, side, side. We have 3 corresponding sides which are all congruent, and we learned that side, side, side was one of our congruence criteria. So our statement would be triangle ABC. It's funny. Triangle ABC is congruent to triangle, and again, we have to be very careful about the order we do this in. Now, it's a little trickier here because we are using A, B, and C, okay, which is the vertex markings, but we have the sides congruent. So what we've got to do is we've got to look at this. We've got to somehow relate angle A to an angle in the second triangle. Well, how do we look at angle A? And how do we characterize angle A to find the corresponding angle in the second triangle? Because the angles aren't marked. Well, there's a few ways to do it. One way, if you're good at determining which side is opposite the angle, we could look at angle A and notice that the side with the double hatch, the double markings, is opposite A. So we can go to this triangle and look at which vertex is opposite the double lined side. So here the double line side is FD, which is opposite vertex E. So that would be the first letter here. Okay, again, A is opposite the double side here. E is opposite the double marked side over here. So A corresponds to E. What about B? Well, B is opposite the triple marked side, and F is opposite the triple marked side, so we would put F next. And then C is opposite the single marked side, and that D would be opposite the same single marked side, so we would have EFD. Now, another way you could have done it is by looking at what sides include the angle. In other words, what are the two sides on either side of the angle? So angle A, okay, is surrounded by the single the single mark and the triple mark. So we have to look and find out which vertex is between the single mark and the triple mark, and here that would be E. We could go to B and notice that B is between the single mark side and the double mark side. It's the angle included between those two sides. So let's locate in the second triangle the single mark and the double mark and look at which angle is included between them. That would be F. So F would correspond to B, and finally the only side left over would be D. So it can be a little tricky at first, but using various techniques, which are all valid, you can come up with the proper order for labeling your congruent triangles. Let's not forget the reason here, which is side, side, side. Okay, so when three corresponding sides of a triangle are congruent, then the triangles themselves are congruent.